Hello, I'm Emmanuel Chukudalo, and I would like to present my coursework on data mining and business intelligence. To begin with, I will start with the Orange software by going to Files, click Open, then it will direct me to where my file is. So I'll click on it and click Open for it to load up. Okay, it's loading. So everything is loading, as you can see in the red points. Okay, and it's loading. The machine part is also loading. Okay, now I chose a data set from the orange sample. So I started by dragging this widget into my worksheet, and then I renamed it to heart disease dataset. Okay, so I double click it and select it from the list of sample datasets that comes with orange. So I selected the heart disease and then close it. And to confirm that everything is loaded and to see how the columns are and everything in the data or in the table, I always double click on the data table to view the columns and the rows. So the data contains 300 instances and 13 columns, of which 7 are categorical and 6 are numerical. So with that said, I'll close this. And now, so I drag the data table from the left hand side, and which is this, so, and connected it to my dataset. Okay, and then I started to take a look at how the visualization of the data. And before that, this data normally data set comes with a dictionary, but this data do not have a dictionary. So I did some research on it to know the individual column what they stand for. I think it's a public file. So I did some Google search and I could find some information on it. So Ethereum and the rest, some are abbreviated and they all have meaning. So that's it. So that one is also found in my documentation. Okay, so secondly, I wanted to see the overview of everything about the table. So I drag the feature statistic widget and connected it to the data, to the heart disease dataset, and this is what appeared. We have the mean and the mode, the zeros, and it calculated the numerical average. So there is a preview, like an insight to what I'm about to start, which is the data mining. So I'm missing data and the rest. They are all here. So we can scroll down to see a review. And there is a distribution, it's a bar chart diagram showing this. So and one more visualization that I did was to also see the scatter plots. And this is how the scatter plots, how the data is scattered. So there is a plot of age in the y-axis and cholesterol level in the y-axis, and the red and all the attributes or the target file is the target column is the diameter narrowing. So the diameter narrowing is of two categories. 0 represents that you do not have diameter narrowing, which is also a representation that you do not have heart disease. And 1, which is a red ink, shows that you are having a diameter narrowing and that you are having a heart disease. So almost those who are having cholesterol is huge. As compared to the rest that I did. So this gives you a graphical look of the likelihood of getting diameter narrowing, which is a heart disease, when you compare it with heart. And the age too is seen as those who are in their 60s to 70s, they are clouded. They show more potential. 50 to 70, they show more potential for getting heart diseases, which is our main target, which we want to mine. Okay, then I'll close this one too. Then there is another one, K-mean, a connected K-mean, and now K-mean interaction. So that one too, let me first open this one. Okay, I have to go back again. I selected some columns. Okay, with the select column widget, we select column widget, we can narrow down. This is a form of cleaning the data by removing some columns which are not necessary in your data mining. You can remove them by selecting them and clicking it to this side, to the left side. That's how I've done. And you can also change the target. You can bring the target as well here and create a new target. Since I did not have I did not upload my file automatically, I don't have the chance to do so, but I can do it here by adding a select column to it so that I can set the target that I want. So I will just send it back and continue on with my presentation and close this one. Then this one was interactive K-mean. That one too is also a good form of separating the cholesterol level with the age. So as you can see, I also plotted the data on a graph on age and cholesterol, and this is how it's separated. But as you keep on with complete control, it will automatically be generating till the data goes exactly in the middle. It tries to divide the number of columns that you have set. So I can click here and it will start another division, and when I try, it will try to center all the colors into all the selected color and pick the middle point of it. And then that is a good way that you can also explore in the data mining. Okay, with that. So basically my work is divided into two parts. The visualization that will help me explore the data part to know much about the data. And one thing about the I also brought in there. I also connected the box plot, which is also here the box plot. Okay, so I brought it from the left widget. It's under the visualize and connected it to the data and to view some outliers. So this is what I got. Now the data set, this is, I think this is the cholesterol. The cholesterol, and there is an outlier. And the outlier is this part. So I need to take off all those by selecting this, so that this data will be what will be used in my mining. I can also go by selecting individual. There is already the targets, so there is no need for me to select that one. And the box plot also works only on the numerical values like age. So you can see the outliers in the age, and when I click on it, the number of age. Now the entries were 303, but it has been reduced to 157 out of 303 instances. So I don't want the data to be reduced to that level. So I went ahead, select gender. Gender is a categorical value, so I cannot get much from it. So I move to this one, to the outlier. These are the outliers. And there's the yellow line is the deviation, and the standard deviation and the mean. Sorry, this is the yellow line is the mean, and the blue line is the standard deviation. Okay, so there is the interquartile range. So anything outside the interquartile range is an outlier. So, and this one too, when I click on it, it says there are 177 out of 303 data, and all these are good depending on what you want to mine. Because we want to show how to filter data, we will take one of them, and use it so that we can see the impacts on our data. The data that we started was 303. So then we'll know what will be left after our cleaning of the data. Okay, so I'll go back and select. I don't want it to be reduced that much, so I'll go back to and select the cholesterol level, and then click. No, it's still, cholesterol level is too low. Okay, so the age, let me see, 50. Okay, let me go in. We want the one with a bigger quarter, the interquarter range. Okay, so we are filtering the data by major vessel colors, colored. Sorry, major vessel colored. So we select the interquarter range. Okay, and one way of reducing interquarter range is to find the log. You can use log to reduce the effect of interquarter range as it brings them to the mean, then standard deviation. Okay, then you have selected it. This is what is left. So we have 241 out of 303. You close it. So let's see if it had an impact. So I connected the data table to it to see. Normally you wouldn't, with a huge data, you wouldn't be able to go through all this like what I'm doing. Okay, so this is what we are getting. It's the same as when we selected the box plot, sorry. Okay, so what I did is that I selected the box plot and right click on it and copied it, instead rather than going back here and to bring box plot again. This means that when you copy it and paste it over here, the same settings that I did inside the box plot will be passed to this one that I've copied. So I copied it over here and then connected the select column widget to it. So this is one, the first cleaning that we have done. And the cleaning that we have done for our data to remain, for our remaining data is instances are 241. So additional filtering could be done here, but as I've already explained with this one, there is no need for me to remove extra column. So I will close it. So then I connected it to the input, and the input, we have two ways of filtering the data. You can, this over here automatically controls all here. So if there is any of the columns in here do not have a missing data, when we select average or most frequent, it will automatically calculate each column and add the average value to any of the column which has a missing data. And if you wish to do it individual with individual columns, you select that individual column that you want the effect to happen to it. Then you select from any of the options here. Then it will have that effect on it. But for the sake of the work, I would like also to further reduce the data to see. So I will say that it should remove all data with missing values. So remove instances with means unknown value. So I clicked on it. So 241 has remained 239. So 2 is also out. And already we lost about 62 or 60 instances from our initial dataset. So this being said, I'll move on to the next. Close. Now the data is pre-processed, so I have to save it. I will first like to view it I first like to view it by connecting the data table to it. So there's the data table to it. You see, double click it and see, okay, everything is intact. And the one with the faded or the shaded color, it means our target. So you can also add a visualization effect here to see the values in here. Since these have not been processed, okay, so all the numerical values, you can see that it calculates the average of every column, then it gives a rating to every column. Okay, then close it. So everything is here. And sorry, we have 239 files and instances. Sorry, I'll close it again. So now I want to save it so that I could use it for the Tableau analysis. So I'll double click on it. I first connected the save widget to the inputs, and it is transferring data. So, and that data is our data table, the left one, the one that has remained. So I'll click here and click save as. Okay, so I would like to name it Tableau heart disease. It's heart disease. So CSV, then save it. When I click save it, to save to the directory where I'm working, the folder where I've saved all my work. So I'll click save to save. So right now it is saved. Then click cancel. Now that data is saved. So that one is what I'm going to use for the Tableau preprocess, the Tableau analysis. Okay. Then I would like to rename this one. So I'll right click and click rename and give it a name like the same name that the blue heart disease. Click enter. Now you have renamed it. Okay, so I wanted to do an additional visualization by connecting a tree to this one, to the data set, to the data. So I click on it and it gave me a nice tree. So there is another form of classification that could be done. Okay. Then moving on. Now our data is now left. We are finished with the cleaning part. And now we are to mine the data. So I connected the test and score widget. You can also right click to select a widget so that you don't always go here to select the widget. So I went there to this one. So I double click on it, and these I connected it. So before then, let me go back and explain things. So since my data is a categorical, we want to mine a categorical, whether yes or no, or 0. Yes is a 1 and no is a 0. So if you have a diameter narrowing, it means that you have a heart disease. And if you get a 0, that means you don't have diameter narrowing and that you don't have a heart disease. Okay, so I connected the logistic regression widget, which is here. The logistic regression widget, which is here, and it's a machine learning widget. So it learns from our data. You can either choose to send the data back here, but you can leave it like that, like what I've left the other ones. I want to zoom it so that, oh sorry, I'm closing it back, and take my picture to this place. Okay, my video. So I connected the rest, like tree, decision tree or tree, and random forest, naive bias, and neural network to see which one will perform better in predicting our data, in predicting whether it is a heart disease or not a heart disease. The accuracy is also very important. Okay, so I double click on it, and here inside the widget you can see these columns. I want to expand it so that we can see it very well. Okay, so these columns shows the accuracy. Like this one is area under the curve of, and this one is the classification accuracy, and this one F1 precision, and the rest. So the higher the value, that means the higher the accuracy, or the higher the better than the other one. So this one is 0.89 and this one is 0.84. So this one under the area under the curve of rock. So ROC means that receiver operating characteristics. So we can click on it so that it will rearrange it. Now it is arranging it in ascending, descending order. We want it to be in ascending order. So neural network is performing better. Neural network got 0.894. Logistic regression got 0.89. Okay, so neural network is probably better for us to use it in predicting our data. And here too in the widget, in the window button, you can I selected 75%, so you should use 75% of the data to do the training, and the rest, the 25% for the testing. So I will select this one rather. So it is loading. So it has loaded. Okay. So you should use 70% of this, 75% of the data for the training and the rest for the test. These are all done automatically by the Orange software. So we are done with that. And let's see which one performed better. Okay. So naive bias is right now, and this one is, I think, is better. So it takes samples, run them about 20 times. This one is 10 times. So run them 10 times with 75% of the data. It will group them into 10 groups and run them in the training session and use the other 25% for the testing. So this is what we got. And naive bias is the best, as I already said. It scored the highest. There's area under the curve. It scored 0.87879, and the rest too. Okay. This one, logistic regression, also performed better. Then I think logistic regression also has performed better in the rest of them. So we can either use logistic regression or naive bias. Okay. For our data mining. Prediction. Okay. So I'm closing this one. And I connected the aggregate to confused matrix. This confused matrix change values to zeros and ones, columns to zeros and ones. That's one of the reasons why I connected this aggregate, so that we can see really what is happening inside here. So this one, they can manually change both categories and numerical values into hot one code. Hot one code basically means that you should change codes to values to zeros and ones, like zeros and ones. So it will find a common ground for them, an average, and then take the lower size to be 0 and the high size to be 1 once. Okay. And that being said, you can visualize it. You can see in the table that it has created an extra column with zeros and ones, zeros and ones, zeros and ones. Okay. So that's what happens in also the data learners there. There we get the machine learners. Sorry. Okay. Then now we are ready for our prediction. So I can either choose logistic regression or naive bias for my prediction. Okay. And thank you for, since I do not have a data to do the predictions, we will end it here and then continue with the Tableau analysis. Thank you.